So for this next video, we're going to be doing something we haven't seen before, and that's for 3D. So an example might be for just 3 meters west, 5 meters north, and 6 meters above the base of the tree. So not only do we have x and y, we're going to add a third dimension. We're going to call it z. So in this example, x is going back and forth here, so that might be like north and south. Y is going east and west. And z gives us the up and down. And vector notation, we're going to put little arrows over things to denote vectors. So vector A is going to equal its x component plus its y component plus its z component. But remember, ax, ay, and z are vectors. So you have to add them like vectors. So if I wanted to know, so unit vector notation. So unit vectors are the following. I, the little hat over it, is a vector that's 1 unit long in the x direction. Okay? Then J is a vector 1 unit long in the y direction. And K is a vector 1 unit long in the z direction. So this vector up here that I would have said is ax plus ay plus z, az, I can say it's a scalar ax in size multiplied by I, because its I is in the x direction, okay, and then ay in the j direction, and so on. To find the magnitude of a vector, we can say the magnitude of A is going to be the square root of ax squared plus ay squared plus az squared. It's just the Pythagorean theorem, but in 3 directions. And we put an absolute value around it to say that we're just finding the magnitude. Top of the next page. So adding and subtracting vectors. In this sense, it's really easy. Okay. Vector A is given by 6i minus 5j plus 4k. That means it's 6 in the x direction, 5 in the y direction, negative 5 in the y direction, and 4 in the z direction. And then vector B is given over here. It only has an x and a z component. It only has I and k. It does not have the j component for the y. So for A plus B, I simply add 6i plus 5k plus 4k. And I'm going to add that to vector B, which is 3i and plus 0j, just to keep things organized, minus 5k. So then I would just combine like terms. I have 6i plus 3i is equal to 9i. And then minus 5j and 0j is minus 5j. And then 4k and minus 5k is minus k. So that's going to give me vector A plus vector B would give me that result. So that's pretty straightforward. Now, for vector A minus vector B, I would take 6i minus 5j plus 4k, and I would subtract 3i plus 0j plus 5k. So that's going to give me 6i minus 3i is 3i. Minus 5j minus 0 is minus 5j. And then plus 4k minus a negative 5k is going to give me plus 9k. And that would be a minus k. Now if I wanted to know the length of A minus B, just practice the length of A minus B, or the magnitude. I would just do the square root of the x term, 3, plus squared plus the y term, which is minus 5 squared plus the z term, 9 squared. And when I solve that, I would find the length of a minus b is going to be equal to 10.72. Now, the direction is a lot trickier since it's going in 3 dimensions, so we're not going to bother with that in this case.